Okay, so now we are going to discuss how we can derive Wien's displacement law from Planck's law. So let us remind what does the Wien's displacement law tells us. It states that the maximum energy density of radiation emitted from a black body is displaced towards the shorter wavelength for the rise of temperature of the black body. That means the maximum number of wavelength is directly proportional to inverse of temperature. That is lambda max directly proportional to 1 by T. So here, as I have written, you can see the denominator of Planck's law can be written as lambda to the power 5 experimental hc by lambda kt minus 1. So now when we differentiate this term, we get this one. Let us suppose that we are differentiating in the form of uv. That is we have applied here the uv formula. So we get 5 lambda to the power 4 experimental hc by lambda kt minus 1 minus lambda to the power 5 hc by lambda square kt experimental hc by lambda kt, which is equal to 0. Then we get 1 minus experimental minus hc by lambda kt is equals to hc by 5 lambda m kt. And from this we get 1 minus experimental of minus x, where x is hc by lambda max kt is equals to x by 5, this one. Thus we have lambda max t is equals to hc by xk is equals to hc by 4.96k, where x is this term, and when we break this term into the placing them with certain values, we get 4.96. And since we know that h is Planck's constant and c is the velocity of light, dividing these things we get 2.9 into 10 to the power minus 3 meter Kelvin. Now if we express in terms of centimeter, lambda max becomes 0.29 by t, which is where we have seen that Wien's displacement also says that lambda max is directly proportional to 1 by t. So that is how we can derive the Wien's displacement law from Planck's law.